Please confirm if I'm audible.
Yeah, yes, you are.
So, a very good evening to everyone who's present over here. And, well, I don't know, it can be a morning, evening, afternoon, wherever you are. As always, it is our utmost pleasure to have you all on board. We are glad that you're here, and we are glad as always for all the energy that you bring to the table. My name is Arijit Rege, and I'm a part of the data team here at Lampros, and you are watching Lampros DAO live. Now, for those of you who are new to our work, let me give you a very quick introduction that Lampros DAO is a collective of builders, researchers, and analysts, and all of us are focused on one thing. We try our very best to turn on chain activity into clear and data driven insights. It is it has been our belief and our driving principle that governance or decentralization and ecosystem behavior in general, it should not be just discussed merely. It is something that has to be measured. It has something that has to be then analyzed and then understood before we put it out. So, with all of that outside, today is something special for all of us. It is something new. Today marks the starting of something that we're doing for the first time. Because over the past few months, if you have observed, from our end, you must have seen dashboards, there are data threads, and protocol insights from Lampros DAO. All of that was focused much of what was happening on chain. But for all of that data to exist, there is a much deeper story that goes on behind all of this. All of this is possible purely because of the technology that makes chains like Ethereum or any other blockchain even work in the first place. And today, that is the layer that we're exploring. And today is also the first of a series that we're starting. Now, you must have heard as a big update that Ethereum just shipped Fusaka, one of its most important and the second one within a year of upgrade. Okay. So, but to make sense of what Fusaka is, what it actually changes, what is getting upgraded, and why it actually matters, all of us need to take a step back and understand the foundations. Why was Ethereum built? What problems did it set out to solve? And how its core design decisions still shape the ecosystem today. So, in this segment that we're starting, we're going to go right from the beginning to the latest of updates. We're going to look at what motivated Ethereum, what gap did it fill, and what were the shortcomings that other chains couldn't do. There are a lot other questions starting from the very basics to the latest things that we're going to explore. And today, for that, we have with us another teammate, Akash. Akash, would you like to introduce yourself? Hello,
Hello,
everyone.
everyone. I'm Akash Yadav from the developer team at Lampros. Nice to meet you all.
So, we hope that you are as excited and as pumped that we are. So, I mean, the stage has been set. So, I'd like to invite Akash to walk us through the core question. First of all, behind all of this, why does Ethereum even exist in the first place? And what it unlocked for the entire Web3 ecosystem?
Okay, so let's start. Uh, we know Bitcoin was introduced and everyone has become a fan of Bitcoin. So, why is it? Because Bitcoin has proved that decentralized digital money is possible. The digital money that can work without borders, means across borders, without banks, without intermediaries, just peers of peers among us managing our own money. Now, Ethereum asked a bigger question: what if blockchain could run programs too, not just transfer value, but execute logic, enforce agreements, and operate applications without a central authority? So, Ethereum was created to be a world computer, a decentralized platform where anyone could write and deploy smart contracts. Now, what are smart contracts? So, smart contracts are simple, like computer programs that run on the blockchain. Think of it like a digital vending machine. You put in money and you press a button, the result is automatic. There is no shopkeeper, there is no negotiation, just rules that execute themselves. Ethereum has brought that idea to everything from finance to art to governance. So, before Ethereum, if you wanted to make a decentralized application, you had to build your own infrastructure, your own blockchain from scratch. Ethereum provided a foundation, a programmable blockchain where developers can focus on building their applications rather than the whole infrastructure. So when I say like a world computer, it seems like a lofty goal. Now, Ethereum cannot be just a single monolithic system developed once and deployed and then forgot means and we expect it to work perfectly. So building this world computer requires careful architecture. It needs layers, each with specific responsibilities. Continuous upgrades are required as the things change, as the world evolves. So, what are these upgrades I'm talking about? So, these upgrades are on the three axes of blockchain. There is security, scalability, and decentralization. So, security means the network should be resistant to attacks and manipulation. It should be a true network. One cannot means malicious actor cannot manipulate it to be give a different output. Then comes scalability. The network must handle many transactions. We are talking about the world computer here, so it needs to handle much more than it is handling now. Then the network must remain open and not controlled by some powerful entities, like it is for the current systems of the world. So these are the three axes, and every blockchain faces what's called the blockchain trilemma. Think of it like a three-legged stool where you can only optimize two legs at once, but never all three. So security, scalability, decentralization, you trade one of them for the rest of two. So during this talk, I will be referencing to our city of Ethereum. So Ethereum means building a blockchain is like building a city. You can have small, tight-knit community where everyone knows each other, like what we have Panchayat Raj in India. It is very decentralized. It is very secure, but it is not scalable. Then we have like big cities like Mumbai, Delhi. They are very scalable, but to make those large scale cities secure, you need more centralized infrastructure, like control, uh, police control, municipality, traffic rules, those kind of things. So these are the two cases like where you are trading one of them. Now Ethereum choose a different path. It prioritizes security and decentralization first, knowing that scalability could be solved through innovation and upgrades in the later years. So technology always is always evolving. Some problems that can be solved today easily were not in the past. So Ethereum chose this path. It traded scalability at first for decentralization secure, and now the upgrades which are coming are making it more scalable, as we will see.
Right. So I think that answers our core question very well. And it was the perfect start. So now that we've set the grounding that we needed, we've looked at why Ethereum was created, what it looked beyond the current existing system as it came into force, and how actually the blockchain trilemma has shaped every design choice from day one. Now, to really understand the upgrades that are happening today, the next step would be, I think, to understand how Ethereum actually works under the hood, the mechanisms behind it. Because when we when we talk about scalability, when we talk about throughputs, or anything that current upgrades like Fusaka touch, we are ultimately talking about how Ethereum's internal structure processes and finalizes transactions. Now, I think after the merge, the structure changed in a fundamental way. So, in this next segment, we are shifting from why, like why everything came into the first place, to the how. So, how is Ethereum, say, organized? How is it put together? How the execution and consensus, the layers of Ethereum, if you know, how are they? How do they exist, and how do they split their responsibilities? Why does this design matter the way it is made modular? And how do these layers coordinate every single block that the network produces? So, let me hand it over again and let us walk through the architecture this time.
Okay, so you mentioned the layers, like when Ethereum switched to proof of stake in the merge in 2022. So it split into two layers, the execution layer and the consensus layer. So think of it like a restaurant. You have the kitchen where the food is prepared and the dining room where decisions are made about what gets served. So they are separate, but they must coordinate perfectly for a restaurant to work. So the Ethereum's kitchen, the execution layer, is where all the actual works happen. All account balances are managed, the transactions are processed, the smart contracts are executed, all the computational work is handled here. Then the dining room is where the which transactions are to be involved in the next block, the order of the blocks. Uh, these all things are decided by the validators, and both of these layers communicate through a well-defined interface. When the execution layer processes a transaction, it would create a state, and that state will be validated by the consensus layer, and then the whole layer agrees on it through a process called finalization. So, in simple terms, the flow, if I would, the flow goes like this for any transaction. All the users submit transactions to the execution layer. That layer processes them, creates a block, and this includes all the smart contract execution and state changes there are. Then the consensus layer validates that block. Now, there are people who have stake ETH in the validators. The consensus layer selects which validator among these gets to propose the next block, and then all the validators vote on whether to accept it or not. Once finalized, that block becomes the part of the permanent history. So now understanding this separation is crucial because upgrades can happen to one layer without necessarily affecting the other layer. This modularity makes upgrade process more flexible and less risky. Now on the screen we see this two types of there are clients. So what these clients are, Ethereum is an open network. So anyone can build their own software to run a node, either execution or consensus, and they can. So these are different clients which are available in the market right now. Anyone joining the Ethereum network can choose one among them, and it is advisable to maintain more diversity for more security. We can see here.
Okay, so now that we've gotten an insight into how things are working, uh, and everyone listening, just keep that in mind that the split between this execution and consensus layer, it is not just theoretical, it is the reason that upgrades work the way they do. We have gotten two excellent analogies, first of the city, now of the restaurant. And uh, you know these are also some reasons why certain bottlenecks show up in the first place. We're going to focus more on these connections later. So now that we understand the overall architecture really well, it is time to go even deeper, one level more. Now, there have been previous upgrades like Cancun. There has been and Shanghai, and then there has been Petra. Now we're at Fusaka. We need to understand the basic ingredients Ethereum works with every single day. the building blocks that define how the network actually runs. There is gas that is used. There are limits on throughput. There are blocks. Now we're talking of blobs as well. Now, you might have been listening of these terms. You might have been seeing these terms in recent updates or latest news, whatever you might come across. So now this is the part of the session today that we string them together and we understand that how are blocks formed, how are they validated, why does gas exist, how does the pillars of the three stool they come together, like how, where is security addressed as a concern, where is scalability addressed. So all of this comes together. So now we are moving from the architecture to the mechanics, the core components that keep ethereum operating in a predictable rhythm, which we'll again see what the exact rhythm is. So again, Akash, over to you.
Okay, so like we need to talk about the building blocks.
Yes.
The most fundamental building block of Ethereum is the block. It is a blockchain, so it needs to be block. So think of block as a page in a ledger book. So each page or each block would contain a timestamp, a list of transactions, who sent what to whom, and what smart contracts were executed. Then comes the reference to the previous block. That's how the chain is created, and information about how much gas is used. We will discuss gas. And the fifth part, with the recent upgrades, would be blobs. Again, we will discuss it later. So first comes the gas. So gas is the second building block of Ethereum. If Ethereum, no, it's Ethereum unit of computational work. So every operation which is executed on blockchain, they're adding two numbers, storing data, calling a smart contract, transferring some funds from here to there, it all costs gas. So let's go back to the city of Ethereum. So blocks are like the infrastructure that allows the city to function. It can be industries, residential blocks, or simple admin blocks. Now, gas is the electricity that powers each block in the city. So now, every 12 seconds, a new block is created. And this happens continuously 24/7, creating an unbroken chain of blocks. So, and it has been happening since 10 years, since the Genesis block. And the remarkable part would be that has been happening without a central coordinator. Thousands of validators, as we see on the screen, would in the world would coordinate through cryptography and game theory to maintain this rhythm. But here's the thing: not all blocks are created equally. One would think that each 12 seconds a block is created, so all blocks are getting the same time. They should be identical, but they are not. Some blocks are full, some are empty, and the difference comes down to the gas. So Ethereum has a gas limit. Currently, it is 60 million gas per block. So this means that each block can only contain a certain amount of computational work. This limit exists to that, like the blocks don't become too large and congest the network. So gas gas in this case would be is also the limiting factor on the block size, and gas is also a measure against spam and abuse. So if all operations were free, attackers could flood the network with meaningless transactions. So let me explain it more clearly with our city of Ethereum again. So I said blocks are the infrastructure in the city. So let's assume residential buildings are the blocks. So the buildings have apartments, transactions in them. So now not all apartments are equal. Not all use the electricity equally, means the gas equally. Some use more electricity than others, some use less. But the energy supply to a building in, in a city is limited. Like all buildings would get same equal amounts of uh, electricity supply. So that's our gas limit on each block. So the number and types of apartments in a building can be variable. There can be In apartment blocks which consume very high electricity, there can be 20 which consume less. So on the blockchain, something similar is happening. Sending a simple payment is just two operations, but executing a smart contract like swapping tokens on decentralized exchange is complex. So the validators cannot decide the order of arrival of transactions and their time. So some blocks are full, some are empty. With a fixed gas limit per block and block each 12 seconds, Ethereum has a theoretical maximum throughput. So this creates a bottleneck. Like uh, you cannot exceed that computational work on Ethereum right now. So the demand for computation is high, the gas prices rise, making the transactions expensive. Then the layer twos solutions are there. So when they were introduced, what they do is settle their transactions on layer one. So that means more computational work on L1 and the gas price rises more. So let's take an example like how layer twos work actually. So imagine a busy bar. So there are multiple patrons in there. So if everyone paid for each drink they took at the moment, the line would never move. So instead, you open a tab, you order drinks over the night, you only swipe once you have at the end when you have to settle your whole tab. So L2s process thousands of transactions off the main chain, then just submit the final bill or summary we can say to Ethereum. Now this summary would be of 1,000 transactions. Again, it would be a large data. So to handle this large data on L1, the third building block, the blobs were introduced in Cancun upgrade. So storing this L2 solutions data, transaction data, large data in regular transactions was very expensive and computed with the regular usage of L1. Even L1 is being used regularly by users. And then there's the large data, much large data from L2s, competing for the same computational output we have discussed earlier. So every time it is submitted, it competes with the regular and drives the cost up for everyone. L1 users, L2 users. So blobs were introduced, this new type of data storage. Think of blobs as a separate lane for public transport bus in like in a city. So regular transactions are the normal cars which function on the main lanes, and then there's our blobs, the public transport bus, which carry large volume of people, but in a separate lane. So this separation means now layer 2 doesn't compete with regular transactions and blobs are much cheaper to store. Blobs are also automatically deleted. They are not permanent. They are just temporary unless until the layer 2 has settled all the transactions. So this is the Ethereum's part to scalability, like not the making the main chain faster, but making it easier and cheaper for L2 solutions to operate. So now here's the fascinating part. When Ethereum started, there were no blobs, there were no L2s. L2s were introduced in a upgrade in the Cancun upgrade in much later. So how does a decentralized network where no one is in charge decide to upgrade? That brings us to the Ethereum's upgrade mechanic.
Uh, so really, again, amazing analogies. And now that we've seen how exactly the mechanism works, like you said, we'll again be moving now to how Ethereum actually changes, because it is a computer that is running 24 into 7. It cannot be shut down, changed, and then put up again. Again, not only that, it it is not centralized at all. So there is no central switch that can be flipped on and off. Yet it continues to evolve, and in significant ways. There was Merge, there was Shanghai, there was Cancun, there was Spectra, and now we have Fusaka. All of this required many, many people across the world to move in a certain synchronization. So now, if you could talk about the machinery behind upgrades, what an upgrade actually means, how are the decisions made for an upgrade, then how are there proposals which then become protocol changes, and why is all of this in sync coordination so critical in a decentralized system? So, but before that, if you could explain what is going on the screen right now.
Oh, yeah, sure. So this is an amazing feat of decentralized engineering from ETH Panda Labs. What we are seeing on the right side, we see like a timer going on. It goes till 12 seconds and then resets. So those that is the 12 second a block gets finalized. So we see a block is proposed. As it is proposed, we see which validators on the world map have means process the data, and then it is the consensus validates it and it is submitted. So you can see on the world map almost instantaneously, all in sync. At every 12 seconds, a new block is being generated.
So, I mean, again, a really beautifully and seriously, it is one of the most beautiful tracking systems that is there for Web3. All of the links we are putting out in the chat as we are going through the live stream. Do visit all of these. I mean, if we are sharing some Twitter based thing or GitHub based thing, all of these communities, all of the people who contribute to these, they work really hard. So if you could maybe give a like, share, repost anything, that would be amazing. For now, let us move on with this session and look what are upgrades, what goes behind an upgrade, how that entire thing works basically. Back to you, Akash.
So now Ethereum has nodes for both the execution layer and the consensus layer. These nodes run on diverse tech stack to provide decentralization security. We have seen that. So now you can publish your own software. It will be compatible with network. Now, how do you decide it is compatible? So you follow a set of rules called protocol, which Ethereum has enforced on all nodes. So an upgrade means a change of rules for that protocol. Now that change can be minor, major, any type. It might add a new feature like blob, fix some security issues, improve the efficiency of current hardware usage or anything, or enable new capabilities. So now here's the tricky part. For an upgrade to work, almost everyone, means each node needs to upgrade simultaneously. If some nodes are running the old version, old set of rules, and some are running the new version, they will disagree about about what's valid, what how to validate the data. The network would split. So this is why Ethereum upgrades are treated with extreme care. Failed upgrade is not only lost funds and broken applications, it's also loss of trust in the network. To avoid all this, there are formal processes called EIPs. EIPs stand for Ethereum Improvement Proposals. So think of it as a formal document that says here's a problem, here's its solution, and then here's how should we should implement it. So let's take the analogy in our city of Ethereum. EIP is like a resident standing up to the town hall and with a written proposal for a new park. They can't just build it. They need to show the plans, explain why it is good for the city, get the architects or developers to say that it is safe, convince the residents, the community that it is worth the cost to the city. Only then the town would agree and start the development. Now, it can also be a businessman. Like a businessman shows up to the meeting, like an L2 solution provider in our Ethereum, proposing a new method of transportation for the city. In this case, like blobs were introduced. So anyone in the Ethereum community can write an EIP. You don't need permission. You just need to draft a clear problem statement, propose a solution, technical specifications like how would you implement it, what, uh, and the rationale for why this change is needed. Once an EIP is proposed to the community in the forums, Discord or meetings, The community debates it. The EIP gets refined based on the feedback. Core developers review it for technical feasibility. Like some upgrades were proposed years back before they were implemented because uh, at the time of proposal, the technology was not advanced enough to be to implement those. So after all this, if it is approved, it gets implemented on the test nets. So like Fusaka, we are discussing, it was first implemented on Holesky before it shut down in October. After that, Sepolia, then Hudi. After all three chains, the testnet were successfully upgraded. Then came the mainnet upgrade. So now, means when does how does all the blocks know when to upgrade? So specific block number is decided, and the upgrade goes live from that block number. Now it is the responsibility of the validators to upgrade that nodes to the new version before the upgrade block number is reached. If they don't, they will be left behind. Their validation will be neglected. Their rewards will be lost. So on the screen we can see uh, this is the roadmap of from Ethereum Foundation. This is the Fusaka we have, means which was uh, upgraded. If you go on the right, you can see Glamster Dam. It is to be upgraded. Now, if you go to Glamster then and click on Learn More, so we are taken to this list of EIPs we are seeing. Now, you can see that there are two scheduled for inclusion. There are two constituents. Some of them are considered for inclusion. And then there's this proposed for inclusion. So if you scroll on that left tab, you can see there are multiple proposed for inclusion, but only some are considered. Among them, only two are finalized as of now. As the time goes, more debate would happen, more things would be considered, and more EIPs would be considered in grade. So you see, all this isn't a technical process. It is deeply social. Any author of EIP needs to build consensus. They need to convince protocol developers, the node operators, application developers, and the users that this change is indeed needed or would improve our experience. So, like this was about Glamsterdam. Now, I have mentioned Cancun upgrade previously. So, it was EIP number 4844, which was discussed in I think 2022. Started discussion in 22, underwent multiple revisions based on the community feedback, was tested extensively, finally went live in March 24, like after 18 to 20 months of revisions. So you cannot rush this process because rushing would only mean more errors, more security bugs which were not tested. So it needs to be carefully considered every step of the way. So if even if on the screen if we are seeing, if you click on any EIP, you will see see the details. It need the all the EIPs are very detailedly explained what needs to be done, what would be the stakeholder impacts, what are the technical specifications, everything. So like this is about this is one EIP. If it is still under discussion when the next upgrade is going to be live, it would be in the next upgrade. It is an ongoing process. The upgrades won't stop forever on Ethereum until and unless we reach the perfect world computer, which I don't think we will ever reach. But it is a process, it is a path to there. So these upgrades are like synchronized dance where thousands of participants must move in perfect harmony. If even a single means some of minority doesn't upgrade, problems like forks can appear. Okay. So what are forks? I would say forks are like what we find on the road. Fork on the road is splitting of road into two. So same way, blockchain splits into two parts on a fork. There are some soft forks. Soft fork means it is backward compatible. Old nodes can still participate. The new rules which are introduced in this case would be a subset of old rule. So, like if we were to consider our city, so adding a new traffic rule doesn't break old cars. So, uh, purchased either years ago or right now can be run on the same road, even if the traffic rule changes somewhat. Now, hard fork on the other end introduce new rules that fundamentally change how the system works. So, like when countries switch from left lane driving to right lane driving, that is a case of hard fork. Like, you need to participate in it. There is no way that some of them say, I will on the old version, I will be on the new version. That cannot be no debate. So most Ethereum upgrades are hard forks because it is in the early stages. The changes are quite significant, so it needs to be hard fork. So like you might find it scary, like so much hard forks. There can be broken applications and everything, but it is necessary because new features are will be drastic changes. So the key is coordination. Every upgrade at the same time, so the network doesn't actually split. Sometimes these hard forks are introduced due to technical errors, like I said. Some of them are still on the old, some of them are on the new. Sometimes it can be philosophical differences too. Like the most famous one in Ethereum's history is the DAO fork in 2016. So there was a hack in this major DAO, and the community was split whether to reverse the hack or not. The community by majority decides that we go back to the block before the hack. Everyone's accounts means accounts would be safe. They would have their balances. So there were some who disagreed with the fork and continued on what became the Ethereum Classic. So there was a fork. There was Ethereum 1.0 and Ethereum Classic. The Classic one had different Ethereum than what the normal working one had. So this was a rare case of philosophical differences led to an actual split. Today, right now, the Ethereum community has adopted a policy of non-intervention in case of contract bugs or loss of funds to maintain credible neutrality, like a trustful network. So these are all the complexities. Ethereum, despite these complexities, Ethereum upgrades have been remarkably successful. The merge was the most complex one. We switched from proof of work to proof of stake. Like the basic functioning of the chain was switched without a hitch. The success comes from years of careful planning, extensive testing, and strong community discussions. Now, a few days back, I think there was Cloudflare was down. Again, AWS was down. It has been happening for quite a few months. Ethereum has never been down in the 10 years. So it is a slow process. It is an ongoing process, but the process can be said to be perfect. Ethereum is not yet perfect. It will reach there, but the process of upgrading Ethereum is perfect right now.
Wow. I mean, we not only saw what upgrades are, what forks are, what a hard fork is, there was some insights that, as we said, not only is it perpetually upgrading, ongoing, undergoing changes and everything, these decisions are not at all impulsive. And the perfect example that Akash gave was that of the EIP 4844, the link to which we have also put in the chat box. For anyone who wants a deep dive to it, please do check it out. As you can see on screen, you also have this link. Go check all of it out. It is so beautifully documented, so perfectly organized. You can actually see all that is happening. And you'll be able to see the beauty of how decentralized systems are working today, how robust it is. And It's really amazing, actually. So I think this discussion we can continue for the whole night actually if we don't stop. But since we have a time constraint, I think we have gone really well through how what upgrades are, how each upgrade works, how it takes into account everyone who wants to participate and who has been a participant of this ecosystem, and how there is always a striving towards improving of performance and keeping the network robust and secure. So as we come to addressing the last part of today's session and the one that will set the tone for the next one, we finally come to the main theme, Fusaka. So, this upgrade, the second one in 1 year, continues Ethereum's journey towards its long term vision of a truly decentralized and world computer platform. Now, today we are setting the stage to understand what it is and why every step in this evolution matters. So, with that, back to you, Akash.
Okay, I need to correct you. You have been saying second upgrade in a year. Actually, it is second upgrade in 5 months. The Fusaka upgrade was in May, and sorry, the Petra upgrade was in May, and Fusaka is in December. Uh, so Ethereum's roadmap isn't a straight line. It's more like a tree. Branches exploring different possibilities. Some branches succeed, some don't. But the tree keeps on growing. The community is constantly exploring new ideas, testing new approaches, pushing the boundaries of what's possible. And that is what we have seen in this year's upgrade. Like the Fusaka upgrade was implemented after 5 months, but it is not that all the discussions and upgrades were done in 5 months only. Both Petra and Fusaka have been in discussions, have been in development parallelly along with each other. The Petra one went first, and then Fusaka came. So both have been in development parallelly, and that's the beauty of it. Like slow process, but ongoing process. Now, as a developer building on Ethereum, understanding this cycle is crucial. The network you are building on today will be different in next year. New features will enable new possibilities. Old patterns might become obsolete. So, staying informed about the upgrades isn't optional; it's essential. So, your applications depend on understanding how Ethereum works. So, you need to be participating in this network. So this is why the EIP process exists to ensure upgrades are well thought, and there is no scope of error. So with each upgrade, Ethereum moves closer to its vision of being a true decentralized world computer. But the work is never done. I have mentioned it before. New challenges will emerge. New solutions are proposed. The network evolves, and that brings us to the Fusaka upgrade. So Fusaka represents another step forward. Will it upgrades almost everything we have discussed today. The gas limits, the blocks, the blocks. So in the next episode, we will see how it addresses the new challenges, introduces new capabilities, and continues the Ethereum's journey.
So, there we are. I guess we have done justice in laying the foundation so that in the next session of this series, we'll be picking up directly with what Fusaka is, how it unfolds, and you know, we have a lot planned for all of you. So there is truly a lot. So let's see what is in store and what Fusaka is solving, what actually changes for Ethereum, what impacts does it have for users and developers. Is there something that the users will notice very significantly? What or how should they adjust if they do? What are the network level effects that it might have? Uh, and how the transition process will happen? And of course, in detail and peripherals and related things of all of these topics. We will be having another amazing deep dive for the next session. As for this session, start putting in your questions into the chat box. We will be addressing those to the best of our abilities. And for today, Akash, if you want to, conclude or summarize all that we saw today or talked about today.
Mm, So the conclusion was simple. Ethereum is a forever process. Reaching perfect Ethereum is a forever process, and we will be seeing more of it in the next episode.
So, guys, now it's all over to you. We are open for your questions. Put them in the chat box and we'll be answering those. Come on, we're actually pumped for your questions. If you have, and apart from the questions as well, if you have any kind of feedback for the way we're presenting, for anything else that you would like to have included in today's session or sessions like these, or you want us to make include in the future sessions, we are all open to feedback. So please do put in everything or anything that you wish for us to know. Also, you can reach out to us on Twitter. We have this streaming on YouTube Live as well. You can put in your questions and we will address those for sure. Do reach out to us, and well, we're waiting for you and your questions and your queries. Pick our brains to the best of your abilities. Come on. Seems that either the session was too well explained, that with all of these analogies of the city and the restaurant and hard forks, or or there have been too many drinks on the tab that you mentioned that there are no questions being asked. So, but again, as we said, we are all open for any and every type of question, query, suggestion, feedback, or even critique that you have. As we mentioned in the beginning, we are a community that is powered by collaborative effort, by logical and analytical questions, questioning what patterns are emerging through data, what upgrades mean for the community. And it is voices like yours and ours that make a difference here. So please put in everything or anything that you want to. Let us address those. And well, I hope that you enjoyed this session today. As always, it has been a pleasure talking to all of you. Thank you so much, Akash, for joining in today. We'll be having a deeper dive again with Akash. Mark your calendars next Tuesday, 15 hours UTC. We'll be meeting again and diving in deep to what Fusaka is and all of its aspects that we can. Do join us. We are pumped and we are excited more than ever for this series. It has been a pleasure having you on board. Thank you for joining Lampros DAO Live. Have a great, great time ahead.